going on, guys? Louis Angel right here with AE Mind Science. We're actually at this location, Thingify, with Brian, the owner, CEO, and the creator of all of these amazing things. And this is a 3D printing company. I don't know if you guys actually, done some research on that or seen some videos. It's a pretty cool, technology, and they're taking full advantage of this and bringing this to the masses, I guess, right?
Absolutely.
So thanks a lot for letting us come here and take a tour of your facility.
Absolutely.
Cool.
When I first started this company, I knew nothing about 3D printing.
Right.
I started this at September 4, 2012. I was in software the whole time, so I didn't know about the 3D printing industry, and I was just lightly following it. The hype at that time hadn't bubbled yet. People really didn't know anything about it. So since I wanted to learn about it, the biggest excuse I could use was to start a business. And it was a legitimate excuse, and since I didn't know anything about it, we first started with a relatively lower entry-level 3D printer. And figured out, okay, how does this thing work? How can we monetize it? And we realized that we couldn't answer any of these questions alone. So what we did was we opened a kiosk in the Irvine Spectrum Center. And the point of that was to get conversations going, because we needed to understand how people saw the technology, what markets were out there. People would just walk up to our booth, and we would show them, hey, this is a 3D printer. Right. You see it working. Here are the samples that it creates. What will you create? What will you do with it?
Right. So tell us about this room. What's the process like? I come in with an idea and we get to sit down.
We wanted to make it like an Imaginarium. Notice the walls. You could write on all of them. Essentially, we just walk people in here, and we want people to start thinking. And we want conversations to flow easily and ideas to flow easily. So I noticed that if you could write on every single surface, we'd be able to just communicate that freely, record everything. And then after we speak, we would take pictures of the walls and then have that for our records.
Okay.
The mirror over there is actually for 3D scanning. We have like a 3D scanning rig that we bring in here if somebody wants to be 3D scanned. And what we do is, it's a lengthy process depending on what they want scanned. So it would be best if they were standing in front of the mirror.
So he came in with his gear and everything? And
he came in with his gear,
helmet and everything.
To be 3D scanned.
Wow.
And then...
So you guys are going to create like a doll out of him?
Yeah, like a tiny action
figure? That's awesome.
And he had a bunch of poses that we had to scan. But what happens is, because it's more of a limitation with our machinery. Like our computers, they couldn't handle that much information. Because it takes it takes 15 frames per second. And with this specific camera that we're using,
what is this one called?
It's called an Artec scanner. It's a 3D scanner, and what it does is it's like similar to a regular camera, but each time it takes a frame, it captures not just the color information of each pixel, it also captures the distance information of each pixel.
Really?
So I could literally take a 3D photograph of you by walking around you. And then after I've walked around you and taken a 3D photograph of you, I could measure that 3D photograph, and it would be your exact measurements. What it does is it literally just uses ink.
Like a regular printer?
Very much like a regular inkjet printer.
I see.
But instead of printing on paper, it would print on this powder. So what it does is it rolls a paper-thin layer of powder onto the platform and then draws on top of it. And then it does it again and again and again using, essentially inkjet ink.
Really?
Right onto the powder. Now this powder is very similar to gypsum powder. The only difference being that they make it, have a special formula for it so that it has a specific hardness and a specific porosity.
Right.
The ink combines with the powder, and what you're left with is this huge block of powder. And what we have to do after it's finished is excavate it from the powder. So we have to dig the pieces off of the powder and blow all of the powder out. And that's what this machine is for. After we have pulled the pieces off, we load them into this machine, and we just use a regular, air blower to blow the powder, any of the additional excess powder off. And then we suck it into the vacuum and recycle it and put it back into the machine.
I see.
And
is this like toxic?
No, 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 no.
I can see.
Yeah, it's non-toxic. Some of them can even print in chocolate. So
Chocolate.
what it does is you have chocolate powder, and the ink, instead of ink, they use cocoa butter.
Wow.
So they would eject the cocoa butter onto the chocolate, and then it would create this complex shape that you would have to dig out of the cocoa powder.
Really?
And then after you pulled all of the cocoa powder out, recycle it. I don't think you could recycle cocoa powder. That would just be gross. But after you've gone through that step, you'd essentially have a piece of candy that tastes like Hershey's. What's amazing right now is the company that started this all. I had mentioned earlier that this technology is 29 years old.
Yeah.
I know because I was born in 1984, and this technology was born in 1984, so it's a very easy number for me to remember.
Same birthday.
But when this technology first came out, the machines were incredibly expensive.
Yeah.
Over $1 million. And now when very recently you could buy these machines from Staples and Home Depot, at least the plastic machines.
The ones that make the product out of plastic, right?
Yeah, the ones that make the product out of plastic. I had mentioned earlier that these machines, I mean, all they do is make one layer after another. And how they actually produce those layers is what differentiates each technology. You have the technology over here that uses inkjet ink, the technology over here that uses plastic. And what the computer tells it to do is, it tells it to move it's essentially like a hot glue gun being controlled by a computer.
Right.
And it tells it how to move to create that layer.
Wow.
And then after it draws that layer, it moves up a bit and then draws another layer on top of it. This is the most lengthy process, but it also uses the cheapest materials.
I see.
Is
that one the most expensive one?
No,
right
actually, this one is the most expensive one. With the video I was showing you earlier with the wrench, it uses this liquid resin and ejects it from special, not necessarily inkjet heads, but special jetting heads to create droplets of this liquid plastic onto the platform. And then it floods it with ultraviolet light to solidify it all in one go.
To make it hard.
To make it hard.
Yeah.
And so this machine, that machine over there that's glowing, and this machine are all based on light. What they do is you have a vat filled with liquid.
Is that the resin?
That's the resin. And on this specific machine, it uses a laser to draw each of the layers. So it would hit the actual resin with the laser, and the moment it hits the resin, the resin solidifies.
I see.
And then this platform would start at the bottom of the resin. It would like dip into the pool of resin and create a paper thin layer of resin. And then it would draw on that paper thin layer. This would go up another paper thin layer. It'll draw another one. It'll go up, draw another one, etc. And eventually you'll have your full piece.
What are your thoughts on 3D printing like body parts? I've been seeing some videos on that. Have you looked into that at all?
We don't do that in-house,
right?
But I think that's a natural progression of the technology, because we already have the digital assets to create those 3D prints. Essentially, you would start with, a 3D model inside a computer. It would essentially be the actual
of a heart or a liver or something like that.
Oh, it really depends on which medical use you're using it for, because it's a whole different field entirely. For example, there was this one recent case where a baby was born with a trachea that couldn't stay open. So what they did was they took a CAT scan of the baby's trachea and used the CAT scan data to generate a 3D model.
Wow.
And this 3D model, they then 3D printed it to form it was a material that can be dissolved by the human body. So they put that surgically into the baby's trachea to hold it open. And it had to be a specific shape because the trachea is a specific shape. Yeah. And so essentially this formed a scaffolding that allowed the trachea to harden around it, and grow stronger so that it would stop imploding, and eventually the body absorbs the material.
Really?
And I mean, that's one of the uses. Another one is 3D printed titanium you would use for grafting bones. The problem with using normal materials is that bones kind of reject other materials. And they have no way of attaching to those other materials. For example, you'd have a metal plate, and you'd have to stick that metal plate on with screws into the bones around it.
It's not going to absorb it naturally.
It's not going to, form around it.
Yeah.
What's fantastic about 3D printing is that you could actually create voids inside a shape. Because you're printing it from scratch, you could have holes right inside the shape. You could have like a honeycomb pattern or like a lattice with branches. So what happens is when you implant that titanium part onto your skull and it has a lattice in it, it allows the bone structures and the bone cells to actually grow into those lattice structures. So it'll form like a place for it to take root, and eventually the bone grows around it and you can't take it off anymore. It's part of your body. You'd have to create a mold to produce parts. And a mold would cost you anywhere from $5,000 to $10,000 for a piece of the mold. And each of those pieces, for example, you put that into tooling, you factor everything in, you've thrown $20,000 into the mold, you've made your pieces, and then you realize it doesn't work. And then you have to spend that money over again.
Redesign
it, to make another mold, and then finally you actually get into the market, and you have to start with 1 million pieces, because that's the only way you're going to get your money back. And if you can't sell those, then you've lost a whole lot of money.
You're bankrupt, you're out of business.
Absolutely. Whereas with this, you have a machine that can essentially create one piece, or 2 pieces, or 3 pieces. It doesn't matter. It could be you only use the material that that it takes to create a piece. You don't have to, like in the old days where they use subtractive machining. You start with a block of material, and then it cuts into that block. Essentially, what you've wasted is everything that you didn't use. You've essentially just thrown it away. It's a lot of waste.
You can't recycle that, right?
You can't recycle it. But with this technology, you're only using exactly what you need. Very little more. And when you're using it as a manufacturing process, you're essentially able to create it on demand. It creates a higher cost per piece, but then you get to test the market, and you get to test your products. So it allows small businesses and small startups to start up faster.
All right, so thanks again, Brian, for giving us a tour of your place. I really appreciate this.
Thank you,
and I'm definitely going to be coming back to get my own little product created. And
we could just 3D scan you. One of the biggest difficulties with 3D scanning is essentially facial and body hair, and
that'd be the easiest thing for me, huh?
Absolutely. We'll even give you a discount because it saves us a lot of trouble.
Put some hair on me. I actually want to see myself with hair again.
Oh yeah.
That'd be awesome. No, but thanks again.
Absolutely.
Man. Check out Thingify, thingify.net. Post the links all down below. Check them out, and they're right here in Irvine, Southern California. If you're not around this area, you can still contact them by going to their website and filling out a form. All right, that's it for right now. See you on the next video.